Right, in the last video we defined what it meant to be a critical number, and in this video we'll look at critical numbers again and maybe another example or two, and then build on the critical number example to figure out what the function f prime says about the function f of x. Right, so in this video, let's take a look at just this function right here, for example. And if you're looking for the critical numbers of this function, we would need to take the derivative, okay, to get 2x minus 8. We would then want to take that derivative function and figure out when does the derivative equal to 0 or when does that derivative not exist. And we can see that the derivative never does not exist. 2x minus 8 is always defined, but 2x minus 8 is equal to 0. When you solve it, you will get 8x is equal to 4. So x equals 4 is a critical number. Okay, so that's the end of that step. Right? Contrast that with another example. Let's look at the function f of x is equal to x to the 2/3 power. Okay, we know that f prime of x is equal to 2/3 x to the 2/3 minus 1, which is the same thing as 2/3 x to the negative 1/3, otherwise known as f prime of x is equal to 2 over 3. And then the negative power means that we're going to send that x to the 1/3 to the denominator. X to the 1/3 is the same thing as the cube root. Okay, so what we're seeing here is that f prime of x now does not exist at x is equal to 0. Okay, when x is equal to 0, this function derivative does not exist. Okay, and it doesn't not exist for all negative numbers. Okay, but x equals 0 is one of those values. So x equals 0 is a critical number of the function f of x is equal to x to the 2/3 power. Okay, so that's another couple examples of the critical number problem. I want to build on that a little bit more in this section because we're trying to, in section 4.3, right, figure out what is the first derivative, how is it related, what does the first derivative, how is it related, or what does it say about the function f? Okay, so that's what we're going to try to look at now, and critical points are the first step in that general direction. Okay, so here's a very important result, right? And it says that if you have a function and that function is differentiable, meaning that the function is always pretty well approximated by its tangent line. So if the function always kind of looks like a tangent line, right? That means that the function, you can find a derivative of it, and that derivative leads to a tangent line that is a good approximation of the function. So if we have that, f prime of x, and then we have the f prime of x function. So let's say that we have a derivative function, and we can say that the derivative is related to the function itself because when the derivative is positive, that means that the function f of x is increasing. Meaning that the function is increasing means that the tangent lines are always sloping upward from right to left. Okay, and when the derivative is negative, the function is decreasing, means that the tangent lines are sloping down from left to right. Okay, so what we can see here is on this part of the graph, the function f of x seems to be decreasing because the tangent lines are sloping downward. And we can see here on this interval that the derivative f prime is less than 0. But on this side, right here, the tangent lines are sloping upward. The function is increasing, and we can see here at that same part that the derivative is positive on that region. Okay, so one tool that will be instrumental in figuring out when a function is increasing or decreasing, for example, is in this function x squared minus 8x. And we found, of course, that the derivative was 2x minus 4. We found in the previous example that a critical number was x is equal to 4, right? And then we can create what's called a sign line, what's called a SIGN, sign line, for f prime of x. And on that sign line, you put the critical numbers. X is equal to 4. That's a critical number. And then you have values. This is the f prime sign line. And then you put numbers to the left and to the right of that critical number. So if you look at all the values, say x less than 4, or the values x greater than 4, pick a value of x less than 4, maybe like 3, or a value of x greater than 4, like 5. Then f prime at 3 is 2 times 3 minus 4, which is a positive number. Okay. And then, let me see. And then f prime at 5 is equal to 2 times 5 minus 4, which is 10 minus 4, which is a positive number. Okay, have I done that right? 2 times 3 minus 8. Oh, this is an 8, Jason. Sorry about that, folks. 2 times x minus 8. So this is an 8. That's why I was confused. This answer comes out to be negative, and the other one is positive. So what we're seeing is that when x is less than 4, the derivative are all negative numbers. And when x is bigger than 4, the derivative is all positive numbers, which says that the function f is decreasing, that the function will be decreasing when x is less than 4, when x is less than 4, and f is increasing when x is greater than 4. Okay, so that is what the function f prime has to say about the function f. It tells you when the function is increasing or decreasing.